So good morning, folks. For the accelerated class, you are expected to be able to calculate grams, AMU, and being able to switch in between. So what we're going to start with is 1H atom. So for the 1H atom, you have to go back to the previous side and see that 1H, located right here, it has 1.0078 AMU. Also, you should pay attention to the fact that there is a conversion factor that's been given to you. In this case, it is 1 AMU is equal to 1.6606 times 10 to the negative 24th. So we are going to be using both pieces of information to determine the next part. So what's given here is 1.0078 AMU. That is the mass of 1H atom. What you're also given is 1 AMU is equal to 1.6606 times 10 to the negative 24 grams. That is a super small number, so just be aware that that is a very, very small number. The two numbers will be working together through the unit conversion process. But before we do that, we should kind of take a look at the numbers to see if there is a significant figures issue. So take a moment to tell me how many significant figures are in each. So you should realize that there is 5 significant figures in each. All right. The reason why they are 5 significant figures each is you count the 1, 2, 3, 4, 5. You count all 5 of these because of the fact that they are sandwiching zeros with real numbers. 1 is a real number, same with 7 and 8, which are sandwiching the zeros, where therefore they are all significant. If they are all significant, then you will be using 5 significant figures as a reference for your final answer. So in this case, you have 1H atom, which is 1.0078 AMU. You should always treat these numbers as fractions, so you should always put it over 1, times the conversion factor. So which unit should go on the bottom to cancel out the AMU? And also, what is the desired unit at the end? Where should that go on this? So the AMU should be on the bottom, because in this case, that is the unit that you want to cancel out. So they cancel out. Next up, you should have the grams on top. You carry this down, so it's 1.6606 grams divided by times 10 to the 24th. Don't forget 10 to the negative 24. Don't forget that part. All right. So once you put this through the calculator, which I highly recommend using a scientific calculator to do so, I will highly recommend Desmos as a way to use that. So the answer in this case, it should be about 1.673555268 times 10 to the negative 24th grams. However, because we only need 5 significant figures, we truncate it here. Because this is greater than 5, we round it up to 1.6736. So that should be the final answer. So it should be 1.6736 times 10 to the negative 24. Sorry, I ran out of room. Okay? So that's how you should do that part. So same thing for the 12C atom. You are doing the same exact AMUs by looking back at carbon, which is exactly 12 AMU right here. So if you look at it, it's 12 AMU. So in this case, what you have is 12 AMU over 1, just like before, times the same number as before, 1.6606, times 10 to the negative 24th grams. Sorry, the writing is a little messy. everything is the same. However, this time you're going to get a bigger number than the 1.6606, which will, as a result, cause you to round up a little bit differently. However, there is one thing to consider first, which is the number of significant figures. Since this case there is only 5, and this one only has how many? That's why, in this case, you have to use 2 significant figures to round up the answer. So in this case, if you put it in the calculator, I'm going to do that. So if you put that in the calculator, it should give you about 1.99272 times 10 to the negative 23rd instead of negative 24th, because this is bigger than 10. But the key part here is you have to know that you have to shorten the significant figures down to just 2 digits. In this case, it will round up to about 2.0 times 10 to the negative 23rd grams as your final answer. Next up, you have 4.35 times 10 to the 6th atoms. So please don't freak out, because there is another way to look at this. So when you have 4.35 times 10 to the 6th atom, you have to remember that it can also be treated as a fraction. Second part is you have to understand that there is an implied relationship between the number of atoms and the mass that they carry. So if you think about this, each atom, as we mentioned before, has the mass of 12 AMU for carbon 12. This way, you can assume and thus be able to carry out the unit conversion from atoms to AMU. So you will just carry out the rest of the calculation much like before. 1.6606 times 10 to the negative 24th grams over 1 AMU. So essentially you will get very similar numbers, and now you will get that answer. Note that you're still following the same significant figures rules, which will get you that. Only 2 significant figures should be at the end. So the answer should be around 8.66832332 times 10 to the negative 17, but we're going to round it up to 8.7 times 10 to the negative 17. Once you move on to the last one, which is 6.02, you're going to do the same thing. 6.022 times 10 to the 23rd atoms, and 1. Do the same thing as before. So this part, once you do the calculation out, it should be around 12 grams. It should be exactly 12 grams. You can obviously rewrite that as scientific notation, but you do not need to. So that's where the basis for certain grams per mole, because this is essentially a single mole, 6.022 times 10 to the 23rd. And that is actually what's really neat about how chemistry has been set up, because each mole of atoms, a certain specific number, 6.022 times 10 to the 23rd atoms, if you have that exact number, you're going to have the exact number of AMU equivalent of grams per mole of atoms. And that's what is molar mass concept will be coming up shortly, and that's what we can use the periodic table for. So let's proceed on to one molecule of methane, which has 1 carbon atom and 4 H atoms. What you can do is add up the mass between the 1 and the 2. So if you think about it, you can add up the 1.0078 AMU plus the 12 AMU, except for making up for it by multiplying this by 4. So if you actually think about it, this one is essentially there's 4 hydrogens. There are 4 hydrogen atoms, and then you add it to the 12 AMU of carbon to get that exact ratio, which should be around 16.0312 AMU as the total amount of mass. So in this case, once you get that, 6.0312 AMU, you're just going to multiply that by one molecule, so therefore it's just one atom, or one molecule of it, times the 1.6606 times 10 to the negative 24th for that part, and you should be able to get the answer. So the answer should be roughly around 2.662 times 10 to the negative 23rd grams for that one molecule of methane. So take a moment to do out the extra credit if you like. I will be giving about 5 points for each. Please let me know if you would like to see a video going over how to do that part.